Hello, I'm back. So I was talking about this earlier. For defer, I think the easiest thing to do, so we have defers in a block. Those are statements. So this is a statement. We won't, when we're emitting the code for this block, we won't emit this at this point. We'll emit it at the end of the block. We'll loop over the only thing there. So I just hesitated for a moment because I thought, okay, does it matter if there's a label? Because my thought here is that the statement essentially ends up being meaningless. And I'm struggling to think of, like, if I put a label here, the label belongs to the statement, not to the defer. And we're not emitting the labels in that scenario. So this, for all intents and purposes, this label would always be ignored, which is a problem. So we're always going to emit the label of the statement. And that's good. We want that because it doesn't matter that this is going to get deferred till later in terms of the actual code generated. The label applies to whatever comes next in terms of the assembly output. So we still want to generate the label no matter what. So we're going to emit the labels for the statement. And then if the expression on the statement is a defer, we're just going to skip. We're not going to emit. So we're going to do all the statements for the block. Then we're going to loop over and emit these. Hey, Hellmeyer32. I am working on a compiler for a programming language I'm designing called Basecode. Okay, so then in the AST evaluator, when we make the defer, scope, defers, and that's pretty much, oh, but that's not exactly what I wanted though. That's what I wanted. There we go. Okay, that's better. What inspired me to do this? I don't know. You know, I saw some videos by John Blow way back beginning of the year, and he was working on his J programming language, and the one part of it that stuck out in my mind at the time was the metaprogramming. And so I thought about exploring that a bit more. Okay, so the defer expression, we create the defer element, we get the current scope block that we're in, we get the defer stack, and we push that pointer onto that and return the element. Everything else works the way that it typically does. And then in block, so now block has that defer stack on it. And then in the emit for the block, so I changed statement. So statement has a public function on it, emit labels, that just does label stuff, because we always want to emit labels, even if it is a defer statement. So then we check if it's a defer statement. We don't want to emit it at this point. We just want to skip over it. Otherwise we emit. Then when we're done emitting all the statements for that block, then I copy, and I'm not too worried about this copy here because it's just pointers. So yeah, there's a little bit of overhead here, but we make a copy of the stack because we don't want to disturb the original. And then we start working the copy. And so while it's not empty, we get the top, we emit it. If it didn't fail, we pop and we keep going till we're done. And for defer, that's pretty much it, I think. So I have a test case file here. So let's run that and see what we get. Is what an infinite loop? I don't think so. Because if it fails, we return. So that's bailing out of the entire emit. If there's nothing in the stack, we don't do anything. Yeah, it returns. If something bad happened, we don't want to keep going. We just bail. All right. So this should actually, this should actually emit after the print, which it does. So we come in here and we call print, and then immediately after we load adder and we do a free. So this is being deferred to the end of the block, and it's generating the label. which is perfect. The label's being generated right before the print, which is what it should be doing. So that looks good. And then we can do, kind of test another scenario here, is we can do defer print A, B, C, and these should actually execute in the reverse order. And it does. There you go. Success. All right. So I would say that was really all that was missing for defer. Pretty straightforward. So let's look at that one. So a couple of these test files I changed for other things I was talking about earlier. I'm going to leave these the way they are. I added constant folding. I did a test file specifically for that. So actually, what we could do is we can get rid of the comment. That's fine. I won't put this in there because that's really where that belongs. And then in short, I took out the casts. I'm actually going to revert this to what it was. And in our defer test, so I put a label here just to test that in fact the code generation is still producing the label and that the defer statement is happening at the end. And then I put a block, an anonymous block here, just to see that these actually get associated to this block and they get emitted in the reverse order. Yeah, and see what's beautiful about this is that anonymous block, that block ends before the outer module block, the implicit block. The free is the very last thing that happens, which is what you would expect. So yeah, that's perfect. Right, so this is being deferred all the way down to here. And okay, so then what I did was in element types, I included stack, and I created a type def for defer stack T, which is just a stack of defer element pointers. And then in defer element, I changed the emit because it just needs to pass through to whatever the expression is. I am assuming the expression is non-null here. We'll see if I manage to blow it up at some point. I can't imagine why it would ever be null, but yeah, we'll see if that ever blows up. If it does, we'll try to figure out what's causing that. Then in statement, I had to expose a separate public interface for just emitting the labels, because that's kind of needs to be something we can do apart from the regular emit. And then in the CPP file for that, hoisted the label emit into that new function. We're calling this in block, right? So I'm counting on whoever is calling this to manage that process appropriately. And the rest here stays the same. And then in block, I added defer stack T. So I added a field, so I have an empty stack. Then we can return a mutable reference to that stack to the outside world, which the AST evaluator uses to put the defers into the stack. And then for emit changed a little bit. And hold on one sec, guys, sorry. Hello, this is Jeff.
This is an urgent call about your student loan.
I know. I didn't expect it to be an actual phone call, but I wasn't quite sure if I recognized the number or not. So I just, it's a stupid automated garbage. Man, I won't even go into it. I really would like to understand like who does that and why they actually think that stuff. Yeah, exactly. No shit, right? Which I don't have. I never went to school. That's my point. It's like whoever's doing it, why are they doing it? Because you're obviously calling people who they shouldn't be. Yeah. Anyway, I realize it's probably just a numbers game for them, but stupid. Stupid, stupid, stupid. Right, so I refactored on emit here. So we loop over the statements. We always emit the labels, but then we check what's inside of the statement. And if the expression is a defer, we don't emit it at that point. Otherwise we do. When we're all done with all the statements for a given block, we then work the defer stack, a copy of the defer stack, and emit those. And that works. And then in the AST evaluator, I just pulled the defer element into a local variable so I can then push it onto the defer stack for the current scope and then set that on the result and return it. And that was it. So that's done. So this guy, hey Synox. So that guy is done. Yay. All right. So next, I'm going to fix the assignment so that it does copying properly. I think that one's pretty simple. So let's go into binary operator. All right, so I'm debating where I want to do this. Do I want to do this in write? Yeah, I don't know. I'm debating what I want to do here. If I want to have the two arms of the decision be here, or if I want to try to abstract that. So if left-hand side Hey, Jacko Musp. Doing well, going good. No, that shouldn't be true. Here it's okay. By the time we get to code emit, we've already done all the resolutions. So the types, if we don't get types here, then something's broken. Okay, so first, if we're trying to assign a scalar to a composite type, that's bad. Ay, bayan kay. I need to start putting errors in here. Okay, so let's go back to the types file. Okay, so let's create a string. Actually, let's assign it to something. And then let's try to assign a scalar value to it. Actually, yeah, that should be fine. Let's do that. So this should fall into this error case. Hey, Lori Master. And for error codes, for now, I'm just going to use this X000. I'm going to come back and consolidate all that. And I think I'm probably going to create like a helper function that will look up strings. Ooh, kaboom. Okay, so it did fall into the error case. Yeah, I mean, I think, is it 100% bug free? Probably not. Definitely not. But in terms of features and functionality, I would now say the parser is alpha. You know, it's complete, feature complete, probably pretty buggy, but for the Bootstrap compiler, it's where it needs to be. Oh, am I using the wrong one? No. Modules and all. Assembly label does not have. That's interesting. It's close. It's close. I'm a little off, but I still think I have a pretty good shot at having a functional Bootstrap compiler towards the new year. All right, so the left-hand side here is a pointer. What's a pointer to? to a struct. Right, okay. Oh, this is the type stuff at the top of that file. Okay, what is this? This is the label. No, we couldn't. It's a U64. So there's a couple things. Why does the assembly label not have a module? Okay, so there is a module there. Now I know what the issue is. Okay. That's buy-in. I don't want to fix this. So the issue here is that the assembly label is actually being built after. So if we go to type of intrinsic, this is happening at fold. This is one of the few things that actually is doing a constant time fold, but there is no module that is current at this point. So in this case, we need to have an optional module. Like a type, jeez. Come on, Jeff. Okay, so if we pass a module pointer in, that's what we use. Otherwise, we look for the current module. So in this case, we use our module the module of the type intrinsic. And that's also going to be true of the address of. And I don't know, are there any other? I think there's only the two. Yeah. Okay. Now, it's still going to error out because the types aren't matching, which is probably another bug. So that's good. Flush these out. Actually, yeah. Except, oh, because it's using type check, that's why. So I need to look at what type check is doing. Okay, so we're getting the right error, but it's I think. I'm trying to fix the location, pulling it from the EST and putting it on the element that gets generated. It's line 28, column 8. That seems really far. Oh, there it is. Line 2, column 18 to 25. Line 2, column, yeah, that's right. Yeah, that's the name. Okay, so why are we not? Should be there. Oh, I know what's wrong. Damn it. I'm an idiot. Yeah, I know what's wrong. Shit. I'm swapping elements, and I'm not. I'm not setting it on the thing that I'm swapping into. Oops. There's going to be a bunch of those. There we go. Okay, so I think I know what the issue here is. So let me now do this. see, pointer type returns composite if the base is a composite type. The pointer isn't itself a composite. And then for type check, if the other side is a numeric type, that's valid. That's a valid thing. So in this case, if left-hand side is pointer, so if it's not a pointer, then we do this. So if it's not a pointer, if left-hand side is not a pointer, then we say, okay, is left-hand side composite and the right-hand side is not, then this is an error. Okay, so the type of should be good. So I guess it's fair to say right now, the only implicit conversion, which, yeah, I guess it's debatable if it's actually conversion, but if you have a U64 on the right-hand side and you have a pointer on the left-hand side, it will course to the address for that pointer. It doesn't have to be casted. Okay, perfect. So this is the error we wanted, right? We have A is a string, that's a composite type. 1 is not a composite type. You can't assign a scalar to a composite. That's bad. Okay. And the inverse is true. Left-hand side is not a composite type. Oops. And the right-hand side is so that handles both ways. Yeah, perfect. Okay, so that works. Now, let's create which is a string. actually, let's do this, hello world. And then let's assign B, A to B. Okay, so this is still, this should not error out. I suppose I should have explicitly declared the type. Not that it really matters. Right, okay. So now, okay, so if we get into this condition and we don't have a mismatch, and we set our copy required flag, so then down here, if copy required, otherwise, let's do this. So it sizes destination, source, and count. this is not 100% correct, and I have to come back. Let's see if we get the copy, at least. It won't be correct. And there's two things I gotta figure out. One, I have to figure out how I'm gonna get the size. And then the other is the copy instruction doesn't have an offset for the source address, so I need to probably do that as a separate instruction. Because if we have on the right hand side, if we had a struct that had a field in it, you know, name, and that was a string, and so you had an instance of that struct, and that was a, so you did a dot name. Well, it needs to offset to that field and copy that part of the a struct into the target string. But let's see what it generates, or if it generates anything. Excuse me. Okay. It does generate the copy. All right, so let's look at this. We load the address of B into I0. We load the address of A into I3. We don't need to load the value though, right? Because there's nothing there. We just need the address, because we're going to copy not from I2, we want to copy from I3 to I0, right? Because this is the address of where that string struct lives in memory. This is the address where this one lives in memory. Okay, so that's one issue right there. Don't think we need to read. So let's look at that. That should get rid of that intermediate load. Because when we're doing this copy, this is always composite to composite, right? It's always struct to struct. And those are internally, or at the bytecode level, those are always addresses. And pointers are not composite, they're just numbers, right? So yeah, there you go. Well, maybe. Why isn't it? Why isn't it loading the... Oh, right. Duh. I know why. Okay. Copy. This should be. You want to address it. Thinking, which is which. There you go, except it's using the wrong register because it's not the value register, it's the address register. There we go. Okay, so we need the size, we need to handle the offset. So if the offset of the field is greater than 0, we want to do move reg to reg. You can do okay, so if we have an offset, we're going to use the fact that move will do an add, an offset. We could do an add here, but it's the same number of register. I mean, it's the same number of arguments. And so what this will do is this will offset the address to the appropriate location. And if we have no offset, then we won't get that move instruction. So to test this, I'll run this once, just to make sure that it didn't blow up. Then in our test file, I'll create a little struct with a string in it, and we'll test that to make sure that, and actually, yeah, I need to put a couple fields in there just to make sure they're not the same, they're not at the start. All right, that looks fine. So let's go here and create the foo struct. So okay. Now we're going to make a foo. Yeah, this is synthwave. There's synthwave, dark wave, and some other stuff in here. Okay, so this is the part we're testing, right? Because 2, 4, so we should see a move instruction that offsets us from the address of foo by 4 bytes so that we get to the F3 field here. Ooh, that's not good. Unable to resolve label. Say what? I wonder if it's the... I don't see why though. Oh, I'm an idiot. Yep, see? Okay, so that was me actually trying to access the type instead of the variable of the type. So yeah, there's something not right there. That's a bug. So I'm going to make a note about that. I got to fix that. That's funny. There you go. Okay. So what does it look like? Cool. 2F8. 2F8. Okay, so let's put a breakpoint here. See if we can figure out. Oh, it has no parent. Huh? think I see the problem. Yeah. Yeah, this has to be on both sides of the... All right. Yeah. Okay. So you can see here, we load the address, and actually, what I probably should do is consolidate that. Right. Which it looks like. I could already do that. That would be nice. Except, yeah, I'm going to have to pass something to say that I want the offset included, because the other code is putting the offset in the load. Originally, I did have the offset in the address, but I moved it to the load. Yeah, see, we're duplicating these. But here, this is correct. So here's what we need to do. So address, so by default, we won't include the offset. So the semantics for everything we have already will continue to work the way it did. But for this, which means I can take that out. This is for self. Means okay. I think that offsetting code I need to the reason I'm calling it here is because I'm trying to get the path or the name. What I need to do is, as part like of address, since it's already calling it once, I mean, I don't need to call it again. What I need to do is have like we pass in some struct, or we pass in this, and it, you know, it's populated when it comes out. That's what I should do. Because then we'll have the information we need, and we don't have to call it again. And actually, that means we can also refactor write, because write doesn't need to do it twice either. Okay, good. So we don't have the extra offsets and moves. They're just in the loads for the other stuff. But here, for the copy, this is exactly right. Other than now we have to figure out how to get the size of the type in there. But this looks correct. So we're indexing past the two shorts, 16-bit integers, to the start of the string struct. Our destination is the address of this string, and we're going to copy those bytes over. This one, there's no offsetting. It's just copy one block to the next block. So now it's just the size. But let's do something. Let's make two foo-bars, and let's assign C.F3 to D.F3. Because I'm kind of curious if that's going to work the way I've got this set up. We shall see. Yeah. I didn't think that was going to work quite right. The question is, why? So 310 is D. So we're not on the left-hand side. Excuse me. We're not. But I bet these probably work, or I hope they do. because those won't be copies. Those will actually be loads and stores because they're scalar types. Yeah. Okay, so this, we get the address of D, we load F1, we store it. Oh. No, that's, wait, I'm so confused. Where's I0? Okay, yeah, it's not accessing, it's not reading. It's not reading C. Why is it not reading C? This 310 is D. Okay, so this is correct, but yeah, it's storing it back into itself. That's not right. Okay, so why is that? Because we're not reading it. We're reading value, but we're not reading. We're reading the right-hand side, but we're not reading the left-hand side. Because, why? This is where we should be falling into. So let's see what's happening. Okay, so left-hand side var, the left-hand side element is a binary operator, which is the member access. Left-hand side is C, right-hand side is F1. Okay, so we're gonna go in here and we're gonna walk This does not seem right. Not sure what I was thinking here. Looks like I got that backwards, but okay. Well, the address of C. Yeah, we don't need to, we just need to address it though. Marco Ja. It's the optimization, or I guess the specific use case for Basecode is to explore metaprogramming. Have I learned anything interesting? Not yet, not really. I mean, I'm still trying to get the compiler to a point where I can even start using it in the way it's intended to be used. Okay, that's definitely wrong. Okay, so somehow so the left-hand side and right-hand side on the binary operator are correct. But when we get them back, when we get the variables from the assembler back, it's like they're both sides are pointing to the same thing. I'm not sure why that is. Okay, so left-hand side C, right-hand side is D. Okay, so as far the parser and the element, the code DOM up to this point is correct. So then we're going to come in here, and the element that we've passed in is the binary operator. I think I figured it out. Maybe. Target element ID is 359. Unfamiliar. Is there any book or reference you could suggest for learning SEO other than the tutorial page? I made a small game by gathering information from here and there. Now I want to learn more complex stuff with more structure from the ground up. Hey LASIK 88. Honestly, I don't really have a book that I could refer to, you to off the top of my head. I'd have to look. And it sounds like you're looking for something less about SDL and more about more complex software design and architecture. Yeah, I'd have to kind of peruse the books that are out there and see if there's really anything good I could recommend. Somebody was asking me about a book the other day, or book reference the other day. Unfortunately, I didn't have a good one then either. Yeah, so here's a challenge you're going to run into. So you mentioned back buffering. Now, I don't know exactly what you're doing with SDL, but if you're... So obviously you can pair like OpenGL or other rendering APIs with SDL. You don't have to just use SDL on its own. So if you're, depending on what you're doing there, it's going to change the answer a little bit. But if you're just doing like old-fashioned poking color bytes into surfaces and then blitting those onto the screen, a lot of that, like the techniques there, that stuff is old, right? You're going to have to probably read older books about it, because modern books don't focus on any of that stuff. Modern books are going to focus on programming against the GPU, right? They're going to focus on if it's OpenGL or Vulkan or whatever API, Direct3D you happen to be using. And that's modern stuff in that realm is very different, right? You have shaders and lots of other stuff. For SDL, again, SDL is kind of, I would mostly call it old school. And it has some escape hatches for you to plug into, newer APIs. Like I know for sure they'll give you an OpenGL context. I think they're adding stuff for, supporting Vulkan and other Metal and other things. But yeah, like the techniques of back buffering and page flipping and 2D drawing into a buffer, that's, again, that's all old stuff. Like I would pretty much say, gee, maybe up to 2003 or 2004, and then that stuff really started to take a back seat. So with all that said, that means you're going to need to probably look for books that are out of print, and you're going to have to work maybe a little bit harder to synthesize that, because obviously those books are not about STL. Those books are going to be about, you know, using systems that were prevalent at that time. So things like direct draw, and other kinds of platform-specific GPU interfaces. And if you go back beyond that, right, if you get into the early 2000s or the late 90s, you're still really kind of, I mean, I'm going to hesitantly say DOS, but there's still a lot of older stuff that's in play in the PC space there. So, yeah, I mean, ultimately, I think your best bet is to focus on tutorials that are online that are geared towards SDL. There may be some books out there, but again, like off the top of my head, I don't know of any. Yeah. Okay, that looks all right. But then yeah, somehow the left-hand side is being tweaked. Are they the same instance? Are they getting reassigned? They are, they're the exact same instance. How is that happening? Oh. Because it is the same ID. No. All right, let's do this. All right, target element is the identifier, which is C, which has 355. This is 327. Yeah, I think I know what the issue is. I think you're going to get varying opinions on whether or not you should be using SDL. I personally think SDL is fine, but you do have to understand that it's a niche, and SDL is not all old stuff, but it does definitely expose a model 2D, right? That is AAA studios are probably not going to be using SDL to do that, right? They're going to write their own stuff. They're going to have their own abstractions on top of all the different rendering options that are out there today. You know, what SDL is giving you is that abstraction, right? It's giving you a consistent interface, and then they worry about whether or not the platform is OpenGL or Direct3D or whatever. SDL also handles other things. It handles input, it handles sound, it handles a variety of other activities. So, I mean, it is a good library. But again, for learning, you know, is there a book out there that's going to tell you, like, I don't know, right? I don't know. C easily with SDL2. I mean, and I'm guessing this is, yeah, it's a Kindle book. I have no idea. I mean, that's it. That's the one book that had that in the title. Here's another one. But now this could be very old. Yeah, this was written in 2002. So this is very old. This was written in 2013. I mean, this one, again, 2013 is long enough now that this book's probably fairly, again, you could read this and you could extract maybe some good information from it, but you're going to have to know that it's out of date. And you're going to have to work at figuring out where things have changed. Now, I don't, you know, it's not going to be significantly out of date because SDL's API hasn't changed that much. SDL2, right? This one that was written in 2002, that's old. This one was written in 2014. This one, yeah, I mean, either of these is probably okay, you know, but again, you have to kind of know there's going to be some differences. And I've never read these. So, but you know, as you can see, the number of books that are available for that topic are there's not many. So online resources are probably your best bet. I think maybe, could be wrong. The issue is right here. Nope, that did not work. There is definitely an issue though. Okay, so that's bugged. This works. So let's do this. There's something about the way these are being cached. It's not right. So the other issue is copy needs to know what the size of the right-hand side is. Which I'm actually just kind of tempted to pass in. We actually have the information that we need. Right there. Okay. Oh, oops. Okay, what do we got here? Yeah, here we go, perfect. Got the size, store, copy. Yeah. Yeah, that's this one right here. Okay, well we know that one's, we know this is there's something bugged in the variable cache there, but this looks correct. Okay, so what? All right, so I'm going to say that the assignment doing copy, I made that change, but we discovered other bugs. And there's refactoring I would like to do. So, so we want to rework that. Okay, before I wrap up, let's review this, and then I want to take a look really quick at fold in binary operator. Okay, so I've been focusing on this types because what I wanted to do was assert that you can't assign a scalar value to a composite. That's an error, and vice versa. Also, that you can assign a composite, you can copy a composite value to another variable, and then it actually generates the copy instruction. This formulation works. And actually, this formulation, if it's two different types, which is why I think it's the cache, it's the naming it's the fact that these are both the same type that something's getting messed up. But anyway, I did try to make two variables of the same composite type and then assign those fields just to see that what would happen. There is an issue here. So, but the issue is not really related to the assignment per se, it's related to the session variable cache. So, I need to review that. I updated the to-do list with a couple things. In the variable class, the method walk to root and calculate offset, I think it's being called too many times. I can consolidate it so it's only happening in a couple spots. The address method on variable, I added a flag to determine whether or not it will include the offset that's calculated. Because we're calling, walk to root and calculate offset, but we weren't using it. In a couple cases, this new case where we're doing copies, it actually comes in handy to be able to include the offset. I added a copy method. So copy really is kind of distinct from write. I didn't want to muddle them together. And so I passed in the variable that we're copying from, and then the size, how many bytes we're going to copy. This still needs some more attention. After I fix the caching issues, then I'll come back, we'll refactor this walk to root and calculate offset. But otherwise, it is in fact generating the correct copy instruction. The address of intrinsic and the type of intrinsic, the module needs to be manually passed in, so I changed the builder function to accept an optional module pointer, because in this context we're after the parsing phase. This is during type checking and constant folding, and so we need to manually pass the module for this intrinsic, which does have a pointer on it, to this new assembly label we're making. We also need to set the location on it so that errors show up in the right spot. Same thing with address of. Element builder, like I say, I just added an optional module pointer to make assembly label, and if that's specified, we use it. Otherwise, we grab whatever the current module pointer is. Binary operator. So as a first pass on this, so I infer the type of the left and right side, and I determine if they're composite. And then if we're not dealing with a pointer on the left-hand side, then we do some comparisons, and then ultimately we determine if they're both composite, if a copy is required. What I would like to do, I think a lot of these rules should move to type check. So I gotta think about that. But if a copy is required, then we do a copy. Otherwise, we do a write. And a binary operator, that was it. And then session, I put a comment in the, so the variable function here on session is kind of the factory that either creates variable instances or returns them from the cache. And I believe there's an issue in the way that I'm caching these right now. So if it's two separate types, it's okay. If it's the same type, it appears to be a problem. So I need to figure out what I'm missing here. It's probably something simple. But because of this, the cache is returning back the same thing, and that's not what we want. It's returning back the same thing when it shouldn't be. But like I say, I'm sure it's a relatively simple defect. Okay, so I think tomorrow I'm going to look at the caching issue a little bit today. If I can fix it, great. If not, it'll be the first thing I try to fix tomorrow. If I do fix it today and get this cleaned up, then I think I want to look at the fold in binary operator. Yeah. So it does nothing right now. So I need to go through and implement this. And essentially what this ends up being is like a little interpreter that takes the elements and applies them, applies the binary operator at compile time. Now some of these, like member access and array subscript, are probably not, like I'm not going to support them in this context. But I don't know. When we get into it, I'll see how that turns out. But yeah, this is a big one. Because with this is going to allow this to work properly. So I think that's going to be next. And I'm sure we'll uncover tons of other bugs in the process. Okay, I'm going to call that a day, and I will be back online tomorrow at 5 a.m. So thanks everybody, and I will see you all tomorrow. Have a good one. Bye.